Picture this. 100,000 years ago, Earth was basically an anthropological house party. Homo sapiens, that's us. The ones currently arguing about it on the internet were just one guest among many. Neanderthals were chilling in Europe, thick-browed and cold-adapted, probably better equipped for winter than you are right now. Homo erectus was still shuffling around Asia, holding the record for longest-running human species like some kind of ancient reality show contestant nobody could vote off. Denisovans were out there too, mysterious and mostly known from a pinky bone and a tooth, which honestly is the most mysterious way to be famous. Homo floresiensis, the so-called hobbits, were living on an island in Indonesia at about 3.5 feet tall, proving that evolution has a sense of humor. Homo naledi was down in a South African cave system doing something with dead bodies that still confuses scientists. Homo luzonensis was on an island in the Philippines, discovered so recently that most people have never even heard the name. At least 9 human species. 9. All on the same planet. All at the same time, give or take. And now there's one. Us. So what happened? Did we do something? Did we, and I say this with love, absolutely murder our way to the top of the family tree? Or is the truth a little messier, a little sadder, and honestly a little more interesting than a simple murder mystery? Let's dig in because the answer is not what you think, and it's definitely not just one answer. First, let's clear something up, because people mix this up constantly. These weren't apes turning into humans in some slow, single-file line, like a game of Mario evolving into Luigi. Human evolution isn't a ladder. It's a bush, a messy, tangled, overpruned bush where multiple species existed side by side, sometimes overlapping for hundreds of thousands of years, sometimes even meeting each other, sometimes even, and stay with me here, hooking up with each other. Yeah, we'll get there. So around 2 million years ago, Homo erectus leaves Africa and starts spreading out across the world, which is an absolutely wild flex for a species with no cars, no maps, and no idea what a continent even is. This one species eventually stretches from Africa all the way to Southeast Asia, surviving for close to 2 million years, which is longer than every other human species combined has managed, us included, and we haven't even hit the 200,000-year mark yet. Erectus is basically the ultimate long-term tenant of the human family tree, and somehow still gets the least amount of screen time in documentaries. Over time, different populations of Erectus and its descendants get isolated in different environments. Some in cold European forests, some in tropical Asian jungles, some on random scattered islands. And isolation is basically evolution's favorite ingredient. Give a population enough time cut off from everyone else, and it starts drifting into something new. That's how you get Neanderthals showing up in Europe and Western Asia. That's how you get Denisovans branching off somewhere in Asia. That's how you get a tiny island population in Indonesia shrinking down into Floresiensis. Because when resources are limited on an island, bigger isn't always better. Sometimes evolution just goes, you know what, let's make them smaller, save on groceries. Meanwhile, back in Africa, around 300,000 years ago, our own species shows up. Homo sapiens. Anatomically modern humans. And for a solid chunk of history after that, we are not the main character. We're just one more species on a crowded planet, and honestly, not even the most impressive one. Neanderthals had bigger brains than us. Bigger brains. Let that sink in for a second before you get too smug about being the last human standing. So if they were smart, strong, and successful for hundreds of thousands of years, why aren't they still around? Why are you not currently sitting next to a Neanderthal at a coffee shop, both of you complaining about your commute? There's no single answer. There's a whole conspiracy board of red string connecting a bunch of different causes, and depending on which species we're talking about, the culprit changes. Let's start with the big one, the one everyone wants to talk about. Neanderthals. Neanderthals lived in Europe and parts of Western Asia for over 300,000 years. They survived multiple ice ages. They made tools, they controlled fire, they buried their dead. They may have made jewelry and cave art, and recent evidence even suggests some pretty complex behavior we used to assume only sapiens were capable of. These were not the dumb, grunting cavemen of old cartoons. These were tough, intelligent, resilient people who thrived in brutal conditions for longer than our own species has even existed as a distinct group. They hunted enormous animals with close-range weapons, which means every single hunt was basically a horror movie where you're the one holding the spear. Starting around 45,000 years ago, as Homo sapiens moved into Europe, the Neanderthal population started to shrink. By about 40,000 years ago, they were gone, vanished, extinct. And that overlap at that window where both species were in the same place at the same time, right before the Neanderthals disappeared, is exactly why so many people jump straight to, "we killed them." It's a satisfying story, right? Dramatic. Simple. Humans, the ultimate invasive species, showed up and wiped out the competition. Case closed, roll credits. Except it's probably not that simple. Scientists have looked hard for evidence of large-scale violence between sapiens and Neanderthals. And it's just not really there. No mass graves full of Neanderthal skeletons with sapien-shaped spear wounds. No archaeological record of some prehistoric genocide. That doesn't mean violence never happened. Individual conflicts probably did happen because humans and humans, no matter the species, tend to fight over resources. But there's no evidence it was the main driver of extinction. So what actually happened? A few things, probably happening all at once, like a slow-motion pileup instead of one dramatic car crash. 1. Climate. The Neanderthals' entire existence was basically an Ice Age success story. They were built for cold, stocky bodies, short limbs, big noses to warm up frigid air, all classic cold weather adaptations. But the climate during their final tens of thousands of years was swinging wildly, getting warmer, then colder, then warmer again in rapid, unstable cycles. Environments they depended on kept shifting under their feet, forests turning into grasslands and back again within a few thousand years. That kind of instability is brutal for any population, especially a relatively small one. And that brings us to point 2, numbers. Genetic evidence suggests Neanderthal populations were never huge. We're talking maybe tens of thousands of individuals spread across a massive territory at any given time, broken up into small scattered groups. Small populations are fragile. They're more vulnerable to disease wiping out a huge percentage of the group at once. They're more vulnerable to inbreeding, and yes, there's genetic evidence of inbreeding in some Neanderthal populations, which never helps long-term survival. They're more vulnerable to a single bad winter, a single failed hunting season, a single new predator or competitor showing up. Imagine trying to keep a small business alive during a recession and a hostile new competitor opening up next door for 10,000 years straight. That's roughly the Neanderthal experience. Point 3. Us. When Homo sapiens arrived in Europe, we weren't necessarily smarter than Neanderthals in some raw, single-stat kind of way, but we may have had some subtle advantages. Larger social networks. Evidence suggests sapiens groups were sometimes more interconnected with other distant groups, trading resources, ideas, and genes across bigger distances, which means more resilience when local conditions turned bad. Possibly more varied diets, more adaptable technology, more efficient hunting strategies in certain environments, including tools that could strike from a distance instead of requiring you to get uncomfortably close to something with tusks. None of these advantages needed to be dramatic. They just needed to be slightly better, consistently over thousands of years, while Neanderthals were already stretched thin by a chaotic climate and tiny scattered populations. Imagine two companies competing in the same shrinking market. One is slightly more efficient, better funded, more adaptable, with supply chains reaching farther away. The other is already struggling with a smaller staff and an unstable environment constantly changing the rules on them. You don't need a hostile takeover for one to slowly absorb the other's market share until the smaller one just can't keep the lights on anymore. That's closer to what probably happened here than any kind of dramatic war. And here's the part that always blows people's minds. The Neanderthals didn't fully disappear. They're still here. Inside you, right now. If your ancestry traces back to anyone outside of Africa, there's a solid chance somewhere between 1% and 2% of your DNA is Neanderthal. Somewhere along that long overlap in Europe and Asia, sapiens and Neanderthals were having children together. Real, actual interbreeding, confirmed by genetics, not myth, not speculation. So in a very real sense, Neanderthals didn't go extinct so much as they got absorbed, diluted into the much larger and faster-growing sapiens population until there just weren't enough full Neanderthals left to count as a separate species anymore. Kind of a wild thought, right? The other species that vanished might partly still be walking around at your local grocery store, complaining about the self-checkout machine. And it's not just cosmetic leftover DNA either. Some of those inherited genes still do things for us today. Certain Neanderthal genes are linked to skin and hair traits, and others are linked to how our immune systems respond to certain diseases, for better and occasionally for worse. There's even research connecting specific Neanderthal gene variants to differences in COVID-19 severity, meaning a genetic gift from a species extinct for 40,000 years was quietly influencing a global pandemic in the 21st century. Okay, let's talk Denisovans, because this one is genuinely one of the strangest stories in all of paleontology. We know shockingly little about what Denisovans actually looked like. Their entire existence as a known species is based on a shockingly small number of fossil fragments. A finger bone, a few teeth, a jawbone, found mostly in a single cave in Siberia, plus later evidence found on the Tibetan plateau. That's basically it. We don't have a Denisovan skeleton to point to and go, there, that's what they looked like. We know they existed almost entirely through DNA, which means Denisovans are basically the human species equivalent of a mysterious online profile with no photos, just a really detailed bio. And that DNA tells us they were interbreeding with both Neanderthals and sapiens. There's actually a documented case of a teenage girl whose DNA showed she was literally half Neanderthal, half Denisovan. A first-generation hybrid found in that same Siberian cave, meaning her Neanderthal mother and Denisovan father were, at some point, in the same cave at the same time, doing what people do. And modern populations in parts of Asia and Oceania, especially in places like Papua New Guinea, carry meaningfully higher percentages of Denisovan DNA than the rest of us, in some cases 4 to 6%, which actually seems to have given those populations useful genetic adaptations, like better oxygen processing at high altitude thanks to genes passed down from Tibetan-adapted Denisovans. So why did Denisovans vanish as a distinct group? Honestly, the honest answer is we don't fully know because we barely know anything about their day-to-day existence in the first place. But the leading theory follows the same basic pattern as the Neanderthals: small, scattered populations, environmental pressures, and eventual absorption into the expanding sapiens population through interbreeding, until Denisovan stopped being a separate lineage and just became a genetic ingredient inside other people, like a spice that got mixed into a much bigger dish until you can't isolate the original flavor anymore. Now let's talk about the tiny ones. The hobbits, Homo floresiensis. This species lived on the Indonesian island of Flores, and they were small. Like really small, as around 3.5 feet tall with a brain roughly the size of a chimpanzee's, and yet there's evidence they made tools and possibly even used fire. They likely evolved from a larger ancestor species that got isolated on the island and shrank over generations. A real documented phenomenon called island dwarfism, where limited resources on small islands favor smaller body sizes because smaller bodies need less food to survive. It happens to other animals too. There were dwarf elephants on that same island, small humans hunting small elephants while giant storks and Komodo dragons roamed around them because Flores apparently decided to be the most chaotic island on Earth. For a long time, scientists assumed Floresiensis went extinct around 50,000 years ago, right around when sapiens arrived in the region, which again fed into that tempting "humans did it" narrative. But more recent research pushed that extinction date back much earlier, possibly closer to 50,000 years before significant sapiens contact even happened, suggesting their disappearance might have had more to do with local environmental factors, possibly a massive volcanic eruption in the region, than any interaction with us at all. The dates are still debated, honestly, and that's kind of the theme of this entire topic. Every time scientists think they've nailed down the timeline, new evidence shows up and shuffles the deck again. And then there's Homo naledi, discovered relatively recently in a South African cave system called Rising Star. This one's weird for a different reason. Naledi had a small, primitive-looking brain, more like something you'd expect from a much older species, but existed far more recently than that brain size would suggest, overlapping in time with early Homo sapiens. There's even controversial evidence suggesting Naledi may have deliberately placed bodies deep in that cave system in a way that looks like intentional burial, which, if true, would be shocking for a species with such a small brain, because we tend to assume complex ritual behavior requires bigger brains. Getting to that chamber requires squeezing through gaps barely wide enough for a human body, meaning Naledi individuals were apparently carrying dead bodies through claustrophobic rock tunnels on purpose, repeatedly. Naledi is a great reminder that we really don't have this whole who's capable of what thing figured out. And let's not forget Homo luzonensis, found on the island of Luzon in the Philippines and only formally described in 2019, which means this species has been officially recognized for less time than some popular smartphones have been on the market. Known mostly from a handful of teeth and small bones, Luzonensis appears to share some surprisingly primitive features alongside more modern ones, almost like evolution was mixing and matching parts from an older toolkit. We genuinely don't know much about how or why they disappeared yet, which is a good reminder that this whole field is still very much a work in progress, not a settled textbook chapter. So, stepping back, what's the actual pattern here? Because if you're watching this hoping for one clean, satisfying villain, I've got some bad news. The villain is complicated, and honestly, the villain is mostly just time, chance, and a changing planet. Every one of these species faced some combination of the same core problems. Climate instability, as the Earth cycled through ice ages and warm periods, sometimes rapidly, disrupting food sources and forcing migrations across unfamiliar terrain. Small population sizes, which made every species more fragile to disease, environmental shocks, and genetic problems from inbreeding. Competition for resources, which intensified whenever ranges started overlapping with other human species, including us. And, in most of the well-documented cases, eventual absorption through interbreeding rather than clean, total extinction. Meaning many of these species didn't so much disappear as get folded into the winning lineage, like a smaller company getting bought out and rebranded instead of shut down entirely. Did Homo sapiens play a role? Almost certainly, yes, at least for the species we overlapped with significantly, like Neanderthals and Denisovans. But playing a role is very different from hunting them to extinction on purpose. It looks a lot more like outcompeting, slowly, generation after generation, through bigger social networks, more adaptable technology, possibly more varied diets, and just enough of an edge to keep growing while other populations kept shrinking. Combine that gradual pressure with unstable climates and already fragile small populations, and you get extinction without a single dramatic battle ever needing to happen. There's actually a broader, slightly unsettling pattern worth mentioning here too. Humans, meaning us, sapiens, have a pretty well-documented track record of arriving in new places and watching large animal populations collapse shortly after. Megafauna, extinctions in Australia, in the Americas, on countless islands, all lining up suspiciously well with human arrival. Giant ground sloths, mammoths, giant kangaroos, enormous flightless birds, entire ecosystems of oversized animals that had never dealt with a coordinated predator before, and then suddenly did. Some researchers think a similar, quieter version of that pattern applied to other human species too, not necessarily through direct violence, but through resource competition, hunting the same prey, using the same land, disrupting the same ecosystems that other species depended on until the other species simply couldn't keep up anymore. So maybe the most honest way to describe what happened isn't we won or we killed them. It's that we were really, really good at spreading, adapting, and reproducing, and being really, really good at spreading, adapting, and reproducing is sometimes just as devastating to other species as outright violence. Just slower, quieter, and a whole lot less cinematic. There's no dramatic music playing while a population slowly shrinks over 10,000 years. There's just fewer births than deaths, year after year, until one day there simply aren't enough people left to keep the lineage going, and nobody at the time realized it was happening. And that raises a genuinely strange question to sit with. If other human species were still around today, what would that even look like? Would Neanderthals have their own nations? Would there be entire debates about Denisovan civil rights? Would Floresiensis have ended up like some sort of protected population, treated the way we treat endangered great apes today? Or would they have been treated as fully equal, fully human, just a different flavor of us? It's uncomfortable to think about, honestly, because history doesn't exactly give us a great track record for how we treat groups we consider different, even when those differences are much smaller than different species. Imagine the immigration debates, the workplace discrimination lawsuits, cable news trying to cover it. Some corners of the internet would absolutely have picked a side to defend with unreasonable intensity. But here's the thing that always gets me the most, the detail that really reframes this whole story. For almost the entire existence of the genus Homo, being alone was not the normal state. Multiple human species sharing the planet, sometimes overlapping for hundreds of thousands of years, was the default. What we're living in right now, one single human species on the entire planet with zero surviving relatives, no other version of human to compare ourselves to, is actually the anomaly. The weird exception, the unusual chapter in a much longer book. We've had this entire planet completely to ourselves, species-wise, for such a tiny sliver of the human story that if you compressed the whole timeline into a single 24-hour day, our current era of total solitude would only cover the last few minutes before midnight. For most of human history, human wasn't one thing. It was several things at the same time, figuring out fire, tools, survival, and eventually each other in their own separate ways across the same planet, sometimes never even meeting, sometimes meeting and trading, sometimes meeting and fighting, and sometimes clearly meeting and falling in love, or at least something adjacent enough to leave genetic evidence behind for scientists to argue about tens of thousands of years later. And now it's just us. The last ones standing, carrying fragments of at least two other species inside our own DNA, walking around as a strange kind of living memorial to everyone who didn't quite make it. Every time you get a sunburn a little too easily, or fight off a cold a little too slowly, or process oxygen a little differently at high altitude, there's a decent chance some ancient relative is quietly still influencing that outcome from tens of thousands of years in the past, having never met you, never known you'd exist, and yet still shaping you anyway. So next time someone calls you a Neanderthal as an insult, just remember, you might genuinely be part Neanderthal. And honestly, they probably would have survived a lot longer if the climate had just calmed down for 5 minutes and given them a break. If you learned something today, you know what to do. And if you've got a theory about which extinct human species deserves its own deep dive next, drop it down in the comments, because trust me, this rabbit hole goes a lot deeper than 9 species and a few cave paintings, and we haven't even scratched the surface of half of them yet.